Hola, Malaga. Thank you for coming here. Thank you for choosing me as your first session of the day. This is going to set the tone for the rest of the conference, right? But I want to ask you to think about multi-cloud. Think about all the different things you have heard about it, whether it's a buzzword or something you may be implementing already, and just try to think about it in a different light in the context of this presentation. So while we go through this, we're going to talk about what is multi-cloud. And don't think too hard. It's early in the mornings, for me even still. The definition that you come up with in your head is probably the right one. It's not that complicated. Then we will discuss, do we really need a multi-cloud option? So remember, I keep asking you, think about all the times that you may have discussed this before, and we'll go through some of the things that we have seen in the past to see if we come to the same conclusion. And then we'll get into the largest part, the meat of this presentation, which is how are multi-cloud solutions being used, in this case, pertaining to the data, so the data clusters, multi-cloud clusters, being used in the real world today. And then finally, we'll talk about how to set up a multi-cloud cluster. Very simple. We'll actually just go over the differences between the different types of nodes that you can select as part of your cluster that makes it a multi-cloud cluster. So what is multi-cloud? Multi-cloud, at the simplest form, is any single architecture that uses two or more cloud providers. And in the context of this presentation, we'll focus on the big three. So that's AWS, Microsoft Azure, and GCP. There's Alibaba Cloud and other clouds that are up and coming. But for the purposes of this talk and how it is structured, we'll focus on the big three. And you've made it through the first part of the presentation. That is multi-cloud. So just keep that definition in mind, because that means it leaves room for much other types of solutions when thinking about this architecture, when you think about multi-cloud. So now, do we need a multi-cloud option? Raise your hand if you think we need a multi-cloud option. Be confident. Okay? Raise your hand if you don't think we need a multi-cloud option. Okay. So we will see, right? Everybody pay attention to the next journey of even just the last few years, and maybe you'll come to your own conclusion as to whether or not we really need a multi-cloud option. In June of 2019, there was what Wired magazine called the catch-22 that broke the internet. And if you remember this particular outage, it was a very big outage that caused a very large section of the internet to be completely offline. The ironic part is that the tools that the Google engineers needed to fix this were also blocked by that outage. So you can imagine they were very, very stressed, and they were dealing with a lot of things in that moment. So what happened there? I have some notes here on my phone, acting as my clicker. What they did was they initiated what should have been a very routine configuration change. They were doing some maintenance, but because of a bug, those pesky bugs in some scheduling software, it actually rerouted the jobs that were meant for a specific area to just start going to more regions and more areas. And when that happened, if you effectively think of all the data that runs through Google, and let's say their normal capacity is being able to have 6 different tunnels with which data could go through, when this outage occurred, 4 of them got blocked. There was only 2 tunnels left. And all of the internet, all of the data that Google usually deals with now had to be bottlenecked through those 2. And that is what resulted in the internet-wide gridlock of that time. But it's not just Google Cloud. AWS also had an outage, one of many, that happened in October of 2019. In their retrospective, they explained that in this particular case, there was a failure in one of their data center systems. So again, because of a bug in some third-party controlling software with all of the sensors, the fans, and the cooling systems in the data centers, it basically spammed them with requests to the point that it just became unresponsive. And when that became unresponsive, racks of servers started to overheat, and that's what caused that particular outage. And on, right? Once we hit the pandemic, once we had coronavirus affect all of our lives, we saw not just how we were encountering outages, but how much we were testing the limits of the public clouds that we have available to us today. A lot of us rely on the services that are provided by the public clouds. And in this case, Microsoft Azure showed how we were kind of stretching that point. So as all of us were coming home, all of us were going on video calls, all of us were just starting to work from home, we saw in one of the reports that they shared, in 1 week that they had when everybody started to go home, around 400 or 44 million daily users were reached on Microsoft Teams, and that generated over 900 million meeting minutes in a single week. So imagine unexpected traffic, right? We know we can deal with some spiky traffic. We can put some settings there to scale it, but who knew that you would get to that type of capacity? I don't think anybody did. And we keep going on and on. I can tell you about stories that happened every month, every year. It goes back on and on. Azure has infrastructure bottlenecks. There was the recent AWS outage in December or November of 2020, which was related to the Kinesis data streams outage. Again, Spotify, Discord, lots of other services went offline because of Google Cloud. And we are reaching now 2022, where now, a lot of Amazon's really devoted cloud customers are starting to question, do we stay on here? Are we going to continue to have to go through all of these outages? These affected millions of people. This particular outage, it had city bike riders, it had Disney Plus viewers affected, it had Delta American Airlines. These were customers that are affected by these outages. So even in this short span of time of all of these different types of outages, we as developers and people who are generally savvy with tech, because I don't want to assume everyone's a developer here, we understand that these will occur, every now and then. We don't expect it to be perfect. We don't expect it, even though we expect those nines to mean something in our service level agreements. But the better picture to see here is that there are no clouds that are spared from these outages. And this is the whole point of why multi-cloud is becoming such an appealing solution to people who are using cloud services today. So then we ask ourselves, what are the outages in 2023? What do we expect to go down? What are we going to have a Slack day off? That's our tech snow day, right? When Slack is down, everybody gets a free 4 hours or however long it gets to go. Or when Atlassian went down, nobody could put Jira tickets in. We were fine with that. What else do the next future things bring? I mean, what happens in 3008? What kinds of problems are we going to have then? Hopefully this is not a problem in that time. Maybe we'll have multi-planet clusters. Maybe we're on Mars by then. Hopefully this problem is solved. But for the foreseeable future, we're going to experience these types of outages. And so a lot of people got together and started to think about that. In June of 2020, there were about 30 IT leaders that got together in this think tank. They all sat around a fancy table and they started to discuss multi-cloud. What does it mean? How do we apply it to our industries? Does this actually solve the problems that we are encountering? How does it fit? How do we move to this model? So they discussed all of these things. And in that report, which is very interesting, I'll link it later if you'd want to read it, there were two particular quotes that I feel speak to the fact that multi-cloud is not a matter of if, but a matter of when. So Gregory Scher, who is the VP of Business Platform Technology at Fiserv, which they serve banks and credit unions and things like that, he says the main driver is what our clients are asking for. We have banks who have an Azure preference. We have banks who have an AWS preference, so on and so on. We don't really get to choose. So if you are someone like Gregory Scher, who is running a company like Fiserv, you have to be able to accommodate your customers, especially if they have to choose where your data is going to go, if they have some obligations or contracts that require them to only use a specific vendor over the other. And if you're going to serve the majority of these customers, obviously being able to be at whatever cloud provider they are at is going to help you. At the same time, it's not always a top-down decision. Sometimes it's from the bottom up. Mohan Pucha, who is the Vice President of Architecture and Digital Strategy at Aon, says we have to be native AWS because of their advanced capabilities in analytics. And we have to be in Azure because, frankly, developers love that ecosystem, and productive developers are probably the best thing. So who wouldn't want productive developers who are just left alone doing what they need to do? But what this points out, and why I like this particular quote and what he sees, is that as developers, as solution architects, as those who are on the ground, who see the problem, start to receive more autonomy, start to receive that decision-making power, they too can also opt in into a multi-cloud option if it suits them, if the tools that they need to use are on another cloud provider. We will get to that in a second. And since then, things have been moving along that trajectory. So in a recent study that was published by Bank of America, they found that out of the 185 organizations that they surveyed, there are about 23% of chief information officers who expect to put their cloud budgets into Microsoft Azure. That's in comparison to the 11% who are planning to spend that on AWS. So remember that last particular outage with AWS where they're deciding, do we leave, do we stay, do we diversify? This is implying that they are going to move off of AWS and go somewhere else, at least try another cloud provider, if not diversify. And lastly, in the cloud database, or not database index, but the cloud index from Nutanix, I think that's how you pronounce it, when they surveyed around 1,500 IT organizations, they found that 64%, almost 2/3 of the organizations, are planning to operate a multi-cloud environment within the next 3 years. So, I'm going to ask you again, do you think we need a multi-cloud option? Raise your hand. That's all I asked for, it's just a larger number. Who still thinks that it doesn't matter, this doesn't sway me, I need to see it? Another answer. Okay, we'll talk later. So, now we get into multi-cloud in the real world. So we see that a lot of the tech industry in general is moving towards a multi-cloud approach. They see the benefits of it. They see how it could solve some of their problems. So now we get into how some were actually being used. Some of it are very rudimentary because this is still brand new, and there's still a lot of things to work out. So this is not the magical solution that says if you spin up a multi-cloud cluster, all your problems go away. That's definitely not what I'm trying to say here. But what I am trying to say is that having a multi-cloud option in your toolbox is something that should be taken advantage of once we find the proper ways to implement it. So the first story, and I apologize for the back, it's pretty hard to read, but it's more of a story anyway. The first solution that we see where multi-cloud clusters are being used, I'll use the example of Canada, where they have a direction for electronic data residency. So what this means is every few years or so, Canada, the public offices, set a kind of guideline as to how they run their IT policies. They put some guidelines and they advise everyone to sort of follow them. And for this particular direction, they said that all sensitive electronic data should be located within the geographic regions of Canada. There are some exceptions, so if the government of Canada has some approved location that's outside, that's okay. But for the most part, any data that is dealt with the public, that is collected by a government agency, needs to be held within the geographic region of Canada. So for example, here, British Columbia, Nova Scotia, that applied to some of their public schooling data. And in Ontario, they actually held their health data in this way. And that brings us to the first client that we had, the first customer that started to experiment with multi-cloud clusters. So this client had an emergency services application, and they were based in Montreal. And as most companies, they were using the AWS Montreal region. Who sees the problem with just being here? Very good, yes. So if this goes down for whatever reason, and that's not unheard of, we've seen all of the outages that have been occurring before. But if AWS Montreal were to ever go down and they did not have any other type of other regions to fail over to or any other contingencies, then your application goes down with that region, right? And that's certainly something we don't want. For an emergency services application, can you imagine going down at that time? Any outage that we have almost always translates to financial loss, reputation loss, or at worst, the loss of life. And so this in particular, they really needed to be a more resilient structure. So how did they solve this? Well, AWS Montreal is the only region in Canada for AWS. So they needed to reach out. They needed to go to, in this case, they found another Montreal region from GCP. And because this is such an important application, they wanted to be absolutely sure that they were always up and running. So for additional fault tolerance, they also spun up 2 additional regions, this time in Azure. So Azure Canada East, which is in Quebec, and Azure Canada Central, which is in Toronto. So now this looks a little bit more resilient. This gives you peace of mind now, and you see that your architecture is based in this way, right? So now that if AWS Montreal were to ever go down, very simply, GCP Montreal can be the failover there. And then if for whatever reason, let's say, I don't know who's seen London Has Fallen. Has anyone seen that movie? Or the other movies? So let's say Montreal has fallen, right? The entire 2 regions are gone. Well, then this is where the Azure regions can step up and fill in the gap. The next solution we'll talk about is something very similar, and this is with Australia. So very similarly, they had an actual law called My Health Records Act of 2012. And it's the same thing that says anytime they're dealing with processing or working with patient data, this also needs to stay within the boundaries of Australia. So if we take a look at what Australia looks like, who knows the regions off the, anybody from Australia here happen to me? No? Okay, I thought I'd ask. In Australia, it's pretty similar. If you need to put your data somewhere, if you need to host it somewhere, Sydney is where you're most likely going to be. And in this case, GCP and AWS are both based in Sydney. Now, if you wanted to acquire another region for that higher availability, you would have to go over to Melbourne. But again, you'd have to reach over across those cloud provider lines and go over into Azure. And so in this particular case, a lot of the Australian clients make use of this, especially because Azure, many of them who they didn't know Azure had 2 additional regions in Canberra, they have a particular requirement that says they have to have in-country disaster recovery. And Azure knew about this, and that's why they put the investment into having very specifically the Australia Central 2 region specifically for that requirement. So again, if you're a company in Australia and you had to abide by this particular act and you were on GCP or AWS, you may have now had to reach over and use Azure to be able to comply with that in-country disaster recovery requirement. And in case you were wondering, Azure also has one in Sydney. So those are the low-hanging fruit. Those are the most common scenarios where people are using multi-cloud clusters today. It's for that higher availability. It's to be able to have that better resiliency. It's taking advantage of the global regions that are there when combining all the 3 cloud providers. But now we'll go into some more specific scenarios. And this one is called the best of all clouds. So we had a client who wanted to integrate a recommendation feature into their application. So what this looks like is they had an application that had internal help desk software. So if you ever called in, there's usually some software that they look up your ticket, or they look up a knowledge base article, and they try to help you solve your problem. And in this particular case, they already were running their production workloads on an AWS MongoDB cluster hosted on AWS. As they started to iterate on this application, and as they wanted to service more of their customers, they were discussing with their developers, they wanted to add an analytics portion to this particular recommendation feature. Essentially what they wanted was when somebody called in, they wanted it to surface up some recommendations based on AutoML to see if they could find a knowledge base article that could help the technician solve that particular customer's problem. And so now the question lies, in order to use AutoML, which is a Google service, how do we get that data over there? What do we usually do to grab data from one and move it to the other? We should all know this. I think we've all encountered this. It's a very painful process. The first option is custom scripting, because who doesn't want to write more code? So this is the way that we've always done it, right? We would do this by creating some really unique, really custom piece of a data pipeline to move the data that we needed into GCP so that we could use AutoML and use that natural language processing, which analyzes the meaning and structure of text, and use that to help bump up those recommendations for the knowledge base. But as a lot of us know, this is a lot of work. It's another separate piece to maintain, and it's even if we try to automate this pain away with things like Kafka, for this particular client, it was just another separate thing that they didn't want to learn, maintain, and continue to upkeep. So the next option for how we can achieve this is to backup and restore. So this, again, is another very common way to do this, right? We would back up, take snapshots of production workloads, and in batches, we would move that over to wherever our destination is that we need this. But again, this particular client did not want to deal with this kind of ETL type of process. And so what worked for them, and caveat, because they were already on MongoDB, they ended up using one of a multi-cloud clusters. So the special thing about a multi-cloud cluster is that you can span these nodes on any of the 3 clouds, but that single data layer is in that single cluster. So what does that mean? They spun up what's called a read-only analytics node in GCP. It's hosted in GCP, and this is what would be feeding that AutoML process. But they were able to keep the electable nodes, aka the production nodes, on AWS. And why this separation is important is because read-only analytics nodes in a multi-cloud cluster isolates these workloads, meaning any long-running queries, anything that you don't want to affect production will stay to this particular node, and you can configure it to be that way. Meanwhile, these don't have any of that interruption that they used to have, and this can be used to prop up the analytics portion that they wanted to add to the help desk. So in this particular case, this is how they were able to achieve what they wanted, adding this recommendation feature into their help desk software by having this architecture in a multi-cloud cluster. And in one moment, I will talk about this one. So this one is a particular auto manufacturing company that brought us this very interesting use case. So another thing that we're seeing from customers who want to use multi-cloud or are curious about it, this particular case was an very popular auto manufacturing company. But I can't, and actually I might be able to name it now because I don't work for MongoDB anymore. This was Tesla. And Tesla, basically they are they are all about cost optimization. And so when they spoke to us, they had workloads running in AWS, some workloads running in AWS. And being focused on cost optimization, when they would have price negotiations on cost, what they did was they spoke to both AWS and Azure at the same time. And so if they were able to get a better deal with Azure, what they wanted to do is when Elon snaps his fingers, they go and they move over to Azure, just like that. They wanted to be able to move that quickly. They wanted to be able to, as soon as they had that meeting and had that good deal that they got on their prices, they wanted to migrate everything over. And for the developers, I feel really bad for them, but imagine having to do that just like that. At the whim of your CEO, say, move all of this data over, we're now being hosted on Azure. So in multi-cloud cluster in MongoDB, it is literally just a command to say change provider. And that is something that has not been seen before. I have not seen it yet since I've given this talk and researched on it. I could be wrong, but as at this point, there's nothing this easy where you could just migrate over from AWS to Azure. And how that happens, it would start migrating some secondaries over to Azure. And then it would re-elect a new primary, because as we all know in replica sets, there's 3 nodes with 1 primary and some secondaries, or more if you set it up that way. And then finally fully move over to Azure. And you can move it back too. That's the great thing about it. This is not to say it will be as quick as a snap of a finger. Obviously, the more data that you have, if your regions are far apart, then the limits of physics still apply. So as the data is migrating over, the fact is that it's possible and that you don't have to upstand any other separate portion. The cluster is on the same database layer. So those are some of the more interesting client examples. And now I'll talk about the developer's choice, because as I mentioned, and as I gave that quote from Mohan Pucha, productive developers are the best thing. Developers are being asked to do more, more, more. And as we start to take a look, as developers, I think we want to use the best tools for the job. Who agrees with me? Who wants to use the best tools for the job? Who wants to use it just because you're an Azure fanboy or fangirl? Okay. Okay, so as we see, there's so many different services offered, and some are better than others, right? Whether that's because you have more experience in it, whether that's because the cloud provider is known to have better services in that, to that extent. Like when you think about Google, you think about really massive data sets. You think about AI and ML. When you think about AWS, I mean, most people are going to be AWS fanboys and fangirls, so they'll just throw everything in AWS. And then Azure, there's a very good, really good community there too when it comes to being a full Microsoft shop. So as developers, what we want is to be able to make use of any of these, no matter which one it is. And a big part of that is the data. So being able to have the data on any of the 3 clouds makes it much easier for us to be able to use those pieces. In that same cloud Nutanix report, it actually showed, as of a survey, 49% of all people that were thinking about multi-cloud say that the biggest challenge is the data portability of being able to actually implement multi-cloud. So with something like a multi-cloud cluster, you are able to have it on the cloud provider that you need, and that piece that 49% think are the hardest part is going away, or it's at least made much easier. We're responsible for even higher availability and lower latency. So we see this with the Canadian example, with the direction for residency, the data, and we saw this in the Australian example. And the majority of other clients use this. We're needing to take advantage of more regions. And as you've seen, Azure is actually pretty good when it comes to global coverage. And so we usually need to reach out and go over to Azure to be able to achieve the higher availability, to be able to give the same experience to all of the clients that we have around the world. And then finally, as we're navigating this type of new solutions, as we're starting to make use of all of the different services on different cloud providers, now our job is to find, how do we become more cloud agnostic? How do we serve our customers wherever they are? Because one big part of that is having the data available whichever cloud provider you use. But a workload in AWS does not easily translate to a workload in Azure, and neither does it translate to a workload in GCP. So that is now the problems that we are encountering now that we start to make use of multi-cloud clusters, is how do we make it more agnostic so that we can take advantage of it? How do we, when at the snap of a finger, we do move it over to Azure, move it over to AWS, are we able to make sure it still works, it still runs, it still we have the knowledge to be able to use it in both places. These are the types of things that we're seeing now and what we're trying to figure out. And lastly, the most popular reason for using a multi-cloud cluster is something to future-proof your platform. And in this case, this dealt with mergers and acquisitions. So very common story, tale as old as time. There is a company that is on AWS. They acquire a company that is a full Microsoft shop, or actually the other way around, and they need to do a cross-cloud migration, right? So it's the same type of issue before where, what do we do? How do we get all of that data over into the destination cloud provider? So again, custom scripting is the first option, right? We don't want to do this. We know the problems of this. We know that it's something unique. It's something bespoke. It's something to maintain. We just want to stay away from things that are always this unique. Option 2, if you are using a MongoDB cluster already, is something called live migration. So this eliminates the need and that complexity instead of doing all of that custom scripting, and you do a live migration over to the destination cloud provider of choice. The biggest problem with this particular solution, and the most annoying part, is once everything has been cut over to, let's say, Azure, the connection string has to be changed. So everything that you see, all the new production traffic, you have to be aware that you need to change it over to the new production string. And that has been a cause of problems for a lot of clients. Once they have done the hard work, everything has moved over, everything's migrated successfully, people are still being pointed to the wrong, older place. And so because of that, the multi-cloud cluster is something that is, again, very appealing to them. And I promise you, I'm not trying to sell this. Again, I don't work for MongoDB anymore. But multi-cloud cluster is where this helps, because when they migrate over to the cloud, again, these are spanning in 3 clouds, but it's the same cluster. They do that by first, They do that by electing 2 new secondaries, or migrating first 2 new secondaries over to Azure. They elect a new primary, which obviously has to be in the new cloud destination, in this case Azure, and then they migrate over the final remaining node. And why this is so appealing is that because this multi-cloud cluster is the same layer, the connection string does not have to change. And you can only imagine for companies that have larger clusters or have a much bigger, more complex architecture, this little thing of not needing to change the connection string is a very, very appealing thing for them, and why a lot of them are actually interested in using a multi-cloud cluster. And so in this way, they're able to future-proof by way of mergers and acquisitions. If they had to run through this similar cross-cloud migration example, then they can do it in this way. And so those are the smattering of things that are actually being used in the real world. So this is still fairly new. And again, this is more dedicated to the data, where you're able to host the data across all the 3 different cloud providers. And now I want to end by saying, in that same think tank, one quote from Brad Lewis, who is the VP of Business and IT Transformation at Dell Technologies, says, if you want to start to have true portability of applications, obviously the data has to go with the application. And so that's why building something like a multi-cloud cluster is something that is worth looking into. So let's go in here. Of course, of course. So you can do this through the Atlas CLI, but I'm going to go through the UI because it's much easier to explain the different nodes that are part of a cluster than to do it via the CLI. All right, so when you create a cluster, who's used MongoDB before? Who's seen MongoDB Atlas? Okay, so the screen should look familiar to you. We have different kinds of clusters. You'll know you choose the cloud provider or region that you want, right? And this is where your replica set. You choose some options. That's great. So now, if you wanted to do a multi-cloud cluster, you would toggle this on here. And what you'll get are these three different things here. You'll see electable nodes, you'll see read-only nodes, and you'll see analytics nodes. So for the most basic type of multi-cloud cluster you could create, you will literally do one on every single cloud provider. And I've checked, unfortunately, there's no region in Malaga or in Spain that I've seen. So somebody here works at Sergey works at Microsoft. Tell them, no, not anymore? Well, I was going to say tell them to get on it because there's no region here. So let's just choose here Paris. And I think the next closest one is London. And so you'll see here, you can set which one is the highest priority node by being the top, right? Obviously a little basic, right? It's the UI, it's to make sure you know what you're doing and whoever's selecting and creating the cluster doesn't make a mistake. But we'll do this, we'll do 1. And this is very helpful. So this comes up because whenever we create a cluster, we always want to have an odd number of nodes in the cluster. If you have an even number of nodes, then you cannot ensure reliable elections, meaning whenever a new primary has to be selected, obviously it needs to be an odd number so that if there's a tiebreaker needs to occur, it can happen, and you can ensure that it's a reliable election of a new primary. All right, so that's the most basic multi-cloud cluster that you can create. And I'm not going to create it. I've already created one because who wants to sit here and watch me create a cluster? But you'll see here, I've already created one, multi-cloud Malaga. And you'll see here, these are the ones that are hosted. So the primary region here is using Azure Paris, and we have 2 other secondary regions. We have one in AWS Paris, and one in, I guess, the one last time I made was GCP Frankfurt. But in this particular case, let's say you wanted to have total read and write availability. You would have to actually bump that number up. You would want to do 2 nodes in your primary region, 2 on your next secondary region, and then 1. We call it a 2-to-1 node distribution. And in that way, you get full read and write availability when it comes to your cluster. And so that is literally it. It is that easy. Obviously, there are way more options that you can configure here. You can configure tags. You can configure your read preferences, your write preferences. You can direct which queries go to which nodes. That is one thing I did not go over, and I can go very quickly. Oops. So very quickly, the electable nodes, these are the ones that are reserved for production. These are the ones that go through and work. These are the ones you use for high availability. These are the ones that you use in your failover strategy. These are the ones that work day to day with your live data. Then there are also things called read-only nodes, which are great for optimizing local reads. So let's say you're expanding, you're moving into other territories, and you need to be able to, give your customers there a better experience, lower latency. If there's a region available there, you can optimize and spin up a node there using one of the regions that are available there, and then using a read tag with preference of local, you can direct and say any queries that are originating from this area or originating from this region will go specifically to that node rather than going to a node that's much farther from that area. And then finally, analytics nodes, we talked about this in the recommendation feature. So this is used mostly for workload isolation. So anytime you need, we call it analytics nodes because usually they're used for long-running processes, like doing some calculations in analytics. And these are the best types of nodes to use for that. And with that said, if you want to learn more about multi-cloud, there's a full tutorial that is on here that's still there, unless MongoDB took it out, but it should be there on how to set up your own cluster. The multi-cloud docs are there as well. And if you find me on Twitter, I can also tweet out these reports that I have cited into this presentation to show you why multi-cloud is becoming more and more popular. Oh, leave it for a couple seconds if you want to take a photo. And with that, I say salamat, that's thank you in Tagalog. If you enjoyed this talk, please tweet about it. Thank you so much to Jay on the Beach. Thank you to all of you for choosing me as your first talk. I hope you at least learned something new or become stronger in your opinion that multi-cloud is just silly and you don't need it. Whichever the case, hopefully this has engaged you in some way. So, muchas gracias. Thank you so much.
Adrienne, yes, and now if you have any questions.
Adrienne, first of all, thank you. It's very timely. In our company, we're looking at multi-cloud strategies. So it's very useful. My question is about network, because to send data between these providers, like egress is a big factor of cost, and also availability or reliability of network connectivity is a question. I'm curious about your experience. Like, did you have outages where you know which party to blame for network issues, or like cost? Are they flexible on cost?
So there are more and more tools that are now being built because of this particular problem. One of them is called Observe Ops, I think, but they're built specifically for this purpose. So let's say you do implement a multi-cloud strategy. You now need tools to be able to view what is happening on both clouds. The manual way to do it is to go into the AWS portal, go into the Azure portal, GCP portal, and manually maintain everything there. Also, if you don't have a widespread, bird's eye view of what's happening on the actual cluster yourself, then that is cause for concern, because sometimes you have costs that skyrocket that you don't see that's happening on one particular cloud provider, or you have some issues like you've mentioned on one that you don't see. So in myself, I do not have direct experience, but what I have seen from what I've read is that more and more tools are being built to be able to hook into all of the cloud providers and give you that view, that overhead view based on which cloud providers that you are using, so that you can make these types of informed decisions. Another thing that I've seen is Google GCP has Anthos, which is how they're using their management of multi-cloud. I believe it's containers. So that's one way, another multi-cloud way that's not dealing specifically with data, but allows you to use a multi-cloud solution is Google Anthos. So I would check that out. I don't know if that answers your question, but that's what I've seen so far.
Thank you. Any other questions, please? Yes,
The question is, in this example, would you still have a single point of failure because you rely on DNS to get to your cluster? So if you have a DNS failure, and I think Facebook had one that affected other cloud providers as well, you still have a failure of your cluster.
Yes, this is where I wish Frank were here. I don't know if he's here. He's a distinguished engineer at Cisco. So yes, networking always is a problem, right? It's similar to the Google Cloud outage where the tools that they needed to fix were blocked by that outage. So yes, in this case, this would still be a single point of failure because that is the bottleneck. So despite having your data across, this is more mitigating the problem of being able to take advantage of all the cloud providers, whether that's the different services that are on there or having the data available there without having to do some custom scripting, without having to deal with migrations. It takes care of the data problem. But in terms of that failover, single point of failure, when it comes to networking, you're correct. That is still a point of failure.
Is it okay? Yeah? Thank you. Any other questions? So in this case, thank you very much for participation. Thank you very much, Adrienne.
Thanks for the questions.
It was really nice.